Hello and welcome to this video on the required practical resistance in a wire for GCSE Physics and Combined Physics. For this required practical, the circuit should be set up as shown, with the ammeter in series with the resistance wire and the voltmeter in parallel. The resistance wire itself should be attached to a meter ruler to make it easier to measure the length. Move the probe to the 100 cm position and take readings of current and potential difference. Move the probe to the 90 cm position and again take readings of current and potential difference. Repeat step 3 for the following distances: 80 cm, 70 cm, 60, 50, 40 and 30 cm. Going below 30 cm risks the wire getting too hot due to the increased current. The extra heat will increase the resistance of the wire and this will affect your results. It's also a safety hazard. Once you have your results of current and potential difference for each of the lengths, the resistance can be calculated using the following equation. Potential difference equals the current times the resistance, or V equals IR. Results of length and resistance can then be plotted on a graph. These results should show that the resistance increases with the length of the wire. This is because as the wire gets longer, there are more lattice ions for the electrons to collide with. And as there are more lattice ions in the way, that increases the frequency of collisions and hence the resistance. The second part of this required practical is to investigate resistors in series and in parallel. R1 and R2 are resistors of the same value. Complete the circuits above and take readings of current and potential difference for each circuit. Use this equation to calculate the resistance. That's V equals I times R. The resistance of the series circuit should be the sum of the resistors. The resistance of the parallel circuit should be less than the value of one of the resistors. If R1 and R2 were both 10 ohms, then the series circuit should have a total resistance of 20 ohms and the parallel circuit should have a resistance of less than 10 ohms. And we can check that using our circuits here. In this example, we have for our series circuit an ammeter reading of 0.15 amps and a voltmeter reading of 3 volts. Using V equals IR, we can substitute in those numbers. So we get 3 equals 0.15 times R. If we rearrange that to make R the subject, we need to divide through by 0.15, and that gives us 3 divided by 0.15 equals R, and that gives us 20 ohms, which is the same as our prediction. For our parallel circuit, again, we're using V equals I times R, and our readings this time are 0.6 amps for the current and 3 volts for the potential difference. So our substitution is 3 equals 0.6 times R. Rearranging it to make R the subject gives us 3 divided by 0.6, and that gives us an answer for R of 5 ohms, which agrees with our prediction that the parallel circuit should have a resistance of less than 10 ohms. And that's all for this video. Thank you so much for listening.